I'm going to show my screen now, and you should see the entire screen. At this point, I am not going to be able to see what anybody types, so...
That's okay, Kevin, because
yeah.
John's actually in the meeting.
Awesome.
I'll rely on John to just let me know if there's a question. I hope you're not overloaded.
It's a VM. What do you... All right, so good evening, everybody. Thanks for coming by. Listen to me talk about tally tables for a little while. My name is Kevin Feasel. I am a database administrator and integration services developer by day. I have a tax shelter by night. And I want to talk about a book that Redgate just recently published, actually during TriPASS Summit. The name of the book is TriPASS. I had the fortune to be able to contribute a chapter to the book. The whole concept is this is akin to the SQL Server MVP deep dives, where you get a bunch of people together who are passionate about SQL Server and let them run free on their topics of interest. The major difference between the MVP deep dives and this is that whereas the MVP deep dives, they have to be SQL Server MVPs, for TriPASS, the concept was this is your first time publishing. So people who have never been published in a technical journal or in a book go and write these chapters. There are some outstanding writers in here. For example, Tara White and Colleen Morrow have great chapters in the book, and all of the royalties go to a charity called Computers for Africa. So I very highly recommend you go out and buy a whole bunch of copies. I don't make a dime on this, unfortunately, but it does go to a good cause. Now let's talk about tally tables. Tally tables are also known as numbers tables because that's all a tally table is. It's a table of numbers. There's one column, typically in or something very short because we're lazy, and it starts either from 0 or 1 and it goes up to a certain number. What is that number? It doesn't really matter that much. In my experience, 20 is a great number because it's small, it fits on 10 pages in memory, and it's still large enough that it's going to handled every problem that I've thrown at it in the past. 10,000 may be high. It may be certain extreme cases. If so, you can add more. That's one of the beautiful parts of a tally table. There's no fixed limit to what you can do. Let's talk about very quick how to create a tally table. On the screen is washed out code, which shows you how to create a tally table. We might be able to darken this without everybody falling asleep.
Ooh, there you go. That worked. One more.
We are going to go full dark. Okay. So we have code to create a tally table. All of the code is online. You can grab it. No worries. But I also want to talk about a second method to create a tally table. The first one creates a physical table and inserts the rows. This comes from Itzhak Ben-Gan and is an in-memory tally table. The way that we build this is through a series of common table expressions. The first CTE just basically gives us 10 rows with data that we don't really care about. We don't care what's in here. We just need to know that there are 10 rows. From there, we create E2, which cross-joins our 10 rows. So 10 times 10 is 100, which is 10 e to the second. Our next tally table is E4, so we take our 100 times 100, giving us 10,000 rows. At this point, we've built 10,000 rows of garbage. Now we're going to take that garbage and make it useful in our CTE tally common table expression. The way that we do that is using the row number window function. Row number essentially says, I want unique incrementing integer values for the entire data set ordered by select null. I don't care which row gets row number 1, which row gets row number 2, which one gets row number 3. I don't care because I'm not looking at the garbage. I'm looking at the row numbers that get generated from running this row number function against the garbage. And what happens is we have the number 0 plus 1 through 10,000. So we have 10,001 consecutive integer values that get returned to us from CTE tally. This all happens in memory extremely fast. In a lot of scenarios, this will be faster than a physical tally table because you don't have to go hit disk. This is true up to typically about 10,000. After 10,000, This particular method slows down quickly because there's a lot more CPU overhead in generating this, whereas with your physical version, you're just reading from disk. So these are the two primary styles of tally tables, or at least how to generate them. Now I'm going to talk about why you'd really want to use a tally table. And there are two reasons that I can come up with fairly quickly because they're the two reasons on my slide. The first reason is to eliminate RBAR processing. RBAR is also known as Row-By-Agonizing-Row. And we are very sensitive to this style of processing for a couple of reasons. One, it's horrible in T-SQL. Two, a lot of us come from a development background which is heavy on procedural languages. I started learning C++. C++ is a very procedural language. You do X, then you do Y, then you do Z. And if you need to do X, Y, and Z a whole bunch of times, you use a loop, like a while loop. You put the while loop together, everything's done, everything's happy. We love this. It's great for a procedural language. T-SQL is not supposed to be a procedural language. When you try to make it a procedural language, we get slow cursor problems. While loops, cursors, those are bad in the world of T-SQL. In Oracle, not so bad. But over here, they're bad. We can use tally tables to replace the use of a cursor or a while loop in a large number of situations. And I'm going to show you some of them tonight. Also, in addition to getting rid of RBAR, we can solve some interesting validation problems that otherwise you might look at and have some difficulty trying to nail down. And that'll be the remainder of my examples. So on with the examples. The first one that I have this evening is the canonical tally table example. I want to split out some text. Specifically, for my example, I have a congressional information table which has some information about people who were in Congress at different points in time. The details aren't that important, except my table has two attributes, an ID and a string. And this string is a comma-delimited set of, well, attributes. Don't worry, the people told me. We're never going to need to analyze this as individual elements in the database. We'll just read it in the application code. And then 2 years later, they come to me and they say, hey, by the way, about that, yeah, we need to be able to read this. Never has happened to me in my life. I'm sure it's never happened to anybody in this room. But what happens when this does happen? Well, us procedural thinkers get our procedural brain kicked into gear, and we say, all right, I need to split out. I've got a whole bunch of rows, and I've got to split out the different attributes within each row. So this looks like two while loops. One while loop to hit each row, one while loop to split out the text inside each row. And our procedural thinker says, this is how I'm going to split out the text in each row. The way that I'll do it is I'll have a variable, string input, which is just, at the beginning, it's just the whole string. Then I'm going to set another variable called value to be the point from the very beginning of the string up to, but not including, the first comma. I'm going to take that, hold it over to the side. Then I'm going to set string input equal to the remainder from first comma, but not including it, over to the end of the statement. I'll take that string input, and that's what I'm going to loop through until I run out of string input to collect. For each one of these, I also have a column number variable that I'm going to use to say, okay, this was the first one that I found, this is the second one, this is the third, and so on. And take that value and that column number, shunt it off into a temporary table. When I'm done, I'll be able to select from that temporary table to give me the values. This is the RBAR way. This is the bad way. You can tell it's bad because there's red text. The good way is a tally table. Before I get to the code, I want to give you a graphical explanation how the tally table is going to work here. We have our string, which is that black text near the top. The first thing I'm going to do is prepend and append commas to my string. The reason I want to do this is we can see the normal case is a comma followed by some text followed by a comma. there are some edge cases here that are different. Special case, word, last number. I don't want special cases. And I know the structure of this data. I know that it'll come in without any leading or trailing commas, so I'm going to slap those on so I don't have to deal with special cases. Once I've done that, I will then take my tally table, an unpivoted of numbers, and conceptually, I'm basically going to pivot it and overlay it top of my string in such a way that the first value in my tally table is the first value in my string, the comma. Second value in my tally table, second value in the string, capital B, and so on, like we have here. From there, I am now interested in figuring out where are the commas. The commas locations are going to tell me where the rest of the information is. So I will collect each comma, and that is the green table on the left. Then I'm going to use the char index function to get the value of the first comma after each comma. So the next comma. You can see they match up like this. Alternatively, I could do a self-join, but the whole idea behind a tally table is we want this to go fast, not slow. So I'd rather not use a self-join. That's slow. Once we're done, we have 1 and 5. Those are commas. The stuff in between is our sweet bottle goodness. That's what we want to collect. So we're going to use the substring function to rip out each comma location and get the details between the commas. The code for this, based on the way that I walked through it, you might think it's pretty difficult, it's pretty convoluted. It's really not. That's one of the beautiful things about a tally table. This is what I walked through in graphical form and took several minutes discussing. Basically, we start with our tally table and we cross-join our information. Normally, cross-joins, you have the klaxon blaring, you've got the red warning lights, everybody's running down to their battle stations. This isn't so bad. The reason that this cross-join isn't so bad is that in our where clause, the first bit of our where clause says where the value of n, which is our tally table number, is less than the length of our string, prepended and appended commas included. So what this says is, if our string is 50 characters wide, then we only need 50 values from our tally table. We don't need the full 20,000. So we're only going to grab the 50 values that we need for this particular. So how many values of n you'll need depends upon the largest value of the string. If the largest value is 100, then we're still going to be on one page and one page only, which is great. We don't have to scan a whole bunch of pages to get one page worth of value. In addition to this, we have another part of our where clause, which is just telling us, only give me the locations that are commas. Because again, that's we know the beginning of separated goodness. In our select clause, I want the ID of the row so that I can later tie this back to where it was, to Bob Dole specifically. Then I want the column number. I'm going to get the column number by using the row number function. Again, row number says give me a unique incrementing integer value for each ID. And I'd like you to order that by n. So the first comma has a row number of 1. In other words, column number value is 1. Second comma, column number value is 2. So on through the string. Once I have those, I have a substring function which says, take that string, prepended, appended commas, give me the value from right after the comma that I'm talking about, give me the value up to, but including the next comma. And that is my value. Now let's go to a demo, see this in action. All right. So here's my Congress information table, and I am going to put in somewhere on the order of about 15,000 rows. 15,000 in the grand scheme of things isn't really all that many. And given that I apparently have an overloaded VM, I may not even go with that many rows. Wow. This is only 400 rows. This is, or 1,200 rows. This is kind of sad, actually. Yeah, 400 times 3, yeah.
Is it now?
Huh. All right, so let's see where we're at now. Normally, I would go through 15,000 rows, but given overloading, I wonder 870 may still be enough for what I would. So here's what our table looks like when we split everything out into the 6 attributes that our comma delimited string had. I'm going to create one of those for my tally table, identical for the rebar version. That way I could, if I wanted, I could run them both simultaneously and compare. But I am going to run them separately. All right. Hopefully it does not end up giving me a bad result due to VM overloading. We'll find out. Given our text, inside the common table expression is exactly the same code that I just walked you through on the slide. Outside, I am using the poor man's pivot to take those rows, those columns, and convert back into rows. So here are the results from operating against the tally table. And you'll see for each person, we have 6 rows associated with each column, and each column is separated out. So now we need to pivot those back to give me 6 columns for each ID. We will do that and it took us somewhere around 1.5 secular slow VM. Now, let's do this the bad way. We are going to use a while loop and say, for each record in our table, I want to go through and do that code that we walked through as the rebar split. Even 870 rows, I'd be willing to guess that it will end up being worse. But we'll find out for sure. Yeah, we are currently at 8 seconds and still going. This is for 800 rows. Here we go. It took us more than 12 seconds to go through 800 rows. That's poor performance. That's go out and get some coffee performance. So in other words, the tally table solution scales so much better than a rebar solution for splitting text. And it's also more concise. We have fewer lines of code. We've got less going on. We don't have extraneous variables that are holding pieces of information through our loops. We don't have to worry about going from our set-based thinking into a procedural mindset to analyze what's going on here. And if we were talking about a table that had 4 dozen, 5 dozen attributes that we're spinning through, then the smaller size of code is going to help your eyes quite a bit, because you won't be scanning, you won't be scrolling up and down nearly as much. So in other words, you get what is essentially a free lunch. You get better performance, better code by tally table instead of going rebar. Our second example is sort of a generalization of the first. This generalization says, okay, instead of splitting on a single delimiter, let's split on a number of delimiters, some of which may be arbitrary. The example that I have here is splitting on camel case. So I have a table that comes in. Basically, it's a flat file that comes in from a set of vendors. And they'll have different questions, diagnostic questions. How is this person feeling today? Is this person blue? Yes. Each question starts with the word is. Each question is of bit type. We want to take those questions, and because we have a whole set of different companies sending in different sets of questions, over in our transactional system, we made the decision, let's unpivot that data. Let's put individual questions on their own run. That way, we don't have to deal with say, a dozen different vendors sending a dozen different question formats and then trying to scale that into one gigantic table with a whole bunch of attributes. So we went with this model. But we didn't want to have is feeling okay as our descriptive text because that isn't, I mean, yeah, it's descriptive enough, but it kind of looks ugly, especially if you have an end user who's looking at it and says, what happened to spaces? Don't you guys understand English? So what we wanted to do is drop the is and then split out on words. Fortunately, all the words were camel-cased, and I didn't have to deal with a scenario where we had 2 capital letters simultaneously. That just makes it a little bit more difficult. It's still a conceivably solvable problem, but a little more difficult. So I want to unpivot the columns, turn them into rows. The way that I'm going to do this is going to the metadata tables, specifically system views, syscolumns, and tables and schemas and types. That will let me get to the column name, and then I'm going to create what I call split column name. At first, all I'm doing is dropping off the is. I'm going to get only the questions from the all question table, which begin with the word is and are bit types. That way, if I have other columns like person, I'm not putting person into a row unnecessarily. So this result set here, I just put into a common table expression that I'm calling questions. And the tally table comes in next. I take this tally table and I cross-join it to our common table expression. From there, I'm interested in all of the values of n, which are less than or equal to the length of my split column name. So just like our first example, if split column name is only 12 characters long, I'm only getting 12 values back. I'm not scanning through all 20,000 rows. I will select the column name and split column name. I'm also going to get the letter, so the substring at the value n from that split column name. This way, you'll be able to see on each individual row one letter. That is our current letter. Here is our current value of n. And the way that I tell if a letter is uppercase or not is I will use the binary checksum function. These are basically all the values in English, so I didn't have to worry about running into a case where maybe if you have a language where binary checksum doesn't work, you may have problems. English, we have no problem with this. Binary checksum works. So I have the binary checksum of the value, the letter, and I'm checking, is this equal to the binary checksum of the lowercase value of the letter? I do binary checksum because that is a case-sensitive checksum. If you do just normal checksum, it is case-insensitive, at least on default correlation. So then, if the two are equal, this is a lowercase letter. If the two differ, this is an uppercase letter. Now I have basically an unpivoted set of results. Each row has one letter. My goal is to take these results, repivot them, and smash them together, putting in spaces where there are uppercase letters. I'm going to use a combination of the stuff function and the for-XML path operator to pull this off. And now we will go to the demo. Demonstration 2. I will create my all questions table, which is the same as what was in the slide. And here is the set of questions. This was our first common table expression, the first slide through. No funny business going on. Is feeling okay? I just dropped off the is. So that's all I've done so far. But I have the columns that I need, and I have them ready for further processing. I'll do that further processing in this split table expression right down here, which is the second piece of code that we looked at on the slides. Somewhere Buck Woody is angry. Now, let us run this again. This is what I have in the split values common table. You'll see, feeling okay has 11 characters, so there are 11 rows. The first, capital F, is uppercase. Come on down to number 8. Capital O is uppercase. down to 11. The next word, the next letter here is for the next column, so we reset our in back to 1. Hungry, and it will go on. We can go down through the data. Yes, this is, these are the results that I'm expecting. But now I need to take those individual letters, pivot them back, put them into one column, and add spaces. So that is what this final bit of code does. From the split values common table expression, I want to get the column name, and I also would like to use the stuff function. Inside the stuff function, I'm using the split values common table expression again, and I'm saying where column names match up. So there is a self-join here, but it's not so bad. There aren't that many rows. What I'm doing is saying, in any event, I want a letter. So give me each letter ordered by the value in. So in the original order that they were in, so that I'm not going to have letters around, like the capital F end up over in position 9 or anything. It's going to be in its appropriate position. And if this is an uppercase letter and the value of in is greater than 1, throw in a space before that letter. So for position 8, capital O, I want a space right before that capital O. And after position 7, lowercase g. I'll use the for XML path operator, which is kind of a hacky way, but is still by far the best route of concatenating strings in SQL Server, short of creating your own concatenation function using the CLR. But that gives me back a concatenated string, and I need to select distinct because for the first record, feeling okay, remember I have 11 rows in my common table expression. I'm going to get back is feeling okay and then feeling space okay 11 separate times, one for each row. So I use select distinct to hide the other 10. And when I run this, we now see is feeling okay does in fact become feeling space okay. And I have this now in an unpivoted format so that if I had, say, I could just load this straight into a question table and I could perform analysis based off of that. So this is how I would use a tally table to split on camel case, or splitting on an arbitrary number of delimiters. The next bit is generating random strings. This is another interesting case, interesting being possibly weird, but in this case, what I had to do was take a set of users and generate a 20-character salt for each user. Just 20 random characters each user. I'm going to use the sys.allObjects system view as a proxy for users. That way, I don't have to create a user table. I don't have to populate it. And it's a good thing because of overload gems, it probably would take forever anyhow. So, once again, we have this business problem. Generate 20 characters for every row. Procedural brain kicks in and says, hang on guys, I got this one. What we need is a cursor. Because in life, we need more cursors. Actually, I had to look up how to write this cursor, and I consider that a point of pride. I believe anybody who can write a cursor from memory is probably focusing on the wrong things. So, for each row in sys.allObjects, I want to go through and, for a counter 1 to 20, generate a character, put that at the end of a string. So we're holding a string variable, 20 characters long. Here you go. Let's go to the next person. 20 characters, here you go. This works. It is functional code, but it's also not that good because, again, this text is green. So that obviously means it's better. We're going to use a tally table to solve this problem. Starting with a common table expression. If you haven't noticed, I love common table expressions. I am going to start with the sys.allObjects system view, and I will cross-join the tally table, where n is between 1 and 20. So I need 20 characters for every user, so I need n from 1 to 20. So again, the result set that it will look like is I will have ID. So the person's ID, I'm going to have the value of n, 1 to 20. I will have a random character. So I'll have an unpivoted list of 20 rows for every user. That's what this table expression is writing. And this method to generate a random character is efficient. It's fast. I'm using it in both the while loop and the common table expression. That way, there's no difference in performance along that measure at least. Once I'm done, I have those 20 rows for every ID. I again need to repivot, smash together, and return that result to the end user. I will once more use the for_XML path operator, but instead of the stuff function, I used substring. Kind of throw it up a little bit. Typically, I would prefer to use stuff over substring because for substring, you have to give a maximum value. In this case, it's fine because, look, every single one needs to be 20 characters. No more, no fewer, 20 characters. Go. But if this later changes to 30 characters or 40 characters, I now have to change the code in 2 places. If I used the stuff function, I would only have to change it in 1 place. There's your trade-off. So I typically would prefer stuff, but you know, you can use substring just as well, and you'll see substring used a lot in sample code online as well. So let us go for demonstration number 3. Generate random characters. I have in my AdventureWorks 2000 database 2,630 something. Let's try that again, because you know if you stop a query and start it again, that'll make it go faster, right? I have approximately 2,600 records in there. I'll let it at that. But okay, so here is my table solution. This is the code that we saw on the slide. No sleight of hand going on here. And given that it was performing relatively slowly, we're going to see how long it actually takes to read all 2,600 rows. All right, 14 seconds. I'm going to run this again, warm cache version, because it's not going to be 14 seconds. At home, during pre-testing, this took about half a second.
It's slow because he's recording.
Yes, I am recording. I am recording for posterity. Okay, so that's 13 seconds. 13 point is what I have here. We'll see the cursor version now, which starts on line 34. We declare some variables, we open a cursor, and we have a while loop, and ends on line 71. So we're running. The good part about this is I do not expect the cursor version to finish quicker than the tally table version. So the tally table version is running about 26 times slower than it should be. I would expect this one to be pretty slow as well. And you can see we've already blown past our 13 seconds. Normally, 26. So this was, in my case, a 2x performance gain. Without this running, without the recording running, it was about a 5x gain. On a more powerful home computer, it was about a 3x gain. So call it like 2 to 5 times performance improvement. And that may not sound like much compared to the first example where there was a ridiculously huge difference in performance, but if I could get 2 to 5x performance gain at the drop of a hat, I'd be making a lot more money than I am now. So lessons learned once again, our tally table is scaling a lot better than a rebar solution. It's also more concise. It's fewer lines of code. It's easier to understand. You don't have these superfluous variables floating around holding values temporarily. Free lunch. So I'm talking about rebar. Hopefully by this point, we're all in agreement, rebar solutions are horrible. Nobody should ever use them under any circumstances ever, except when you have to, or when it makes sense to. But I'd now like to talk about some other interesting scenarios that don't directly compare to, look at how much better this is than a rebar solution, because that's easy. That's shooting fish in a barrel. This is going to be a little bit more interesting, hopefully. In this scenario, I have a data set, and I want to validate that data set. And there can be a number of errors for any row. The way I would liken this to is, say you've got a website, or you're on a website, you're filling out a form, and you click the submit button that says, hey, your first name is wrong. Your name being Jean-Claude Van Damme. And you say, okay, whatever, the spaces apparently don't exist in first name, so I'll just change that. Hey, your last name is wrong. Okay, whatever, spaces don't exist in the last name. Hey, your phone number format is wrong. Okay, I'm going to fill this phone number out. And it just goes on because it's showing you one message at a time. That's annoying. Extremely annoying is when you have a file that comes in once a week. And the resulting file set says, hey, there was an error on row number 8. So next week, file comes in. Hey, there's a different error on row number 8. Now you have exacerbated this problem because instead of it being on a website that you can fill in information relatively quickly, it's a weekly process. We want to get rid of that. We want to show all of the errors simultaneously, send it all back to the end user so that they can correct everything all at once, fix it for the next load. That's what we're going to do here. In this case, I'm going to contrast two set-based methods. The first one is a union combination of business rules. The other one will be using a tally table to check the rules. Our sample data is a contrived. I have a couple of text fields. I have a couple of numeric fields. The rules that I put in place are all values, every attribute should have a value. Now you can see that field 2 and number 2 are nullable. We say, business-wise, we know that there have been problems on the source system side where they've given us bad data that has been null. So we need to be able to hold a null value in our staging table so that we can tell them, hey, your data is bad. Also, our convoluted example is time series, which is monotonically increasing. What I mean is field 1 had better be less than or equal to field 2. Number 1 had better be less than or equal to number 2. So we have 4 separate rules. Any row could violate any combination of these 4 rules. We don't want to send back just the first rule that fails. We want to send back all of the rules that fail. The base solution that you could do within T-SQL is you have each check. The first check would say, okay, give me IDs and error messages where field 2 is null, where the number 2 is null, where field 1 is greater than field 2, where number 1 is greater than number 2. You can use the union all operator to combine these separate data sets, bring them together, and now you have one set of error messages that you can turn back to the source. This works. There's no problem with using this. But there's sort of a problem that I'll get into. I have jumped ahead. All right. Now, here is the tally table way. This is the first time in which the tally table method is not more concise than the alternative that I'm presenting. In our tally table method, we are generating a tally table. And technically, you could argue this is not really a tally table because there's a second attribute on here, error message. Fair enough. But I would argue this is more of a generalization of the tally table pattern, implementing an error message in addition. If you did this often enough or had common error messages, throw this out in its own table. It is now an error message table. You are using the tally table pattern with a not truly tallied table. That's how awesome this is. what are we going to do once we've generated our table that has a number and it has an error message? What we're going to do is cross-join our data set to the tally table. And then we'll say where n is 1 and field 2 is 1. So here is where we're putting in that business or that validation check. Check where field 2 is null. Or where n is 2 and number 2 is null. Or n is 3 and the field 1 is greater than field 2, so on. We'll go and take a look at the demo, at which point we'll be able to do a few comparisons, and where I'll be able to say it depends. Because I haven't really said that very much tonight, and it wouldn't be a talk without saying that a few times. So I'm going to create a data table. I'm also going to show actual execution plans. Inside our data temporary table, we have some records. In a basic glance, we will have some errors. There are some null values. Now, here are our two methods. First is our union all for table scans. Second one is our tally table. I run them quickly. Both of them the same data sets. I have to scroll down to show you. Yeah, this is the same data set. The execute plan says that our first union all method is 88% of the batch according to the query analyzer's estimate. The reason is we have 4 separate scans of our data table. The tally table version has a single scan and then a constant scan. That constant scan was our common table expression building up our tally. And we have a nested loops join. So in this scenario, we've gone from 4 scans to 1 scan. Great improvement. However, here is where I get to talk about it depends. Basically, in this case, the tally table performed better. But let me throw out a different case. Instead of a dozen rows where most of them had errors, say you've got a billion rows and you know that only a few of them have errors. And you only have those 4 rules. What if we created indexes for those 4 rules so that I can find very quickly a few records on each that violate each rule? In that case, our union all solution goes from 4 scans to 4 seeks of just a few records in a large table. Our tally table is non-sargeable. That where clause, you cannot use the indexes in that particular where clause, where you might have a filter on some num2 where you're looking to see if it's null or not. You can't use that as well as a filter on field 2 to see if it's null, as well as a filter on, or as an index on fields 1 and 2. So you're not able to do that. You're going to have to scan the table. And for a large enough data set with few enough errors, it may make sense to split out those rules separately. Once you have a lot of error messages, the more errors you have or the larger percentage of error rows in your file, the better off the tally table solution is going to look. So this is the first time where I cannot tell you, go out and build a tally table and go out and use a tally table for this problem, because depending on the nature of the problem, you may see your performance using the older style, the union all style. So now I'd like to move on to the next problem, unique ranges. This is a case that I ran into where we have a table which has a begin value and an end value. In my case, these were dates. In this scenario, I'm going to use integers, a little bit easier to read. And the idea is that we have a beginning value and an ending value for each person. The business people said there should never be any overlap. So, if somebody's in here from January through March, and then they come back through March 30th. If they have from April 1st to June 30th, that's cool. That's no problem. But if they come back in February, that's a problem because we have overlap. The application developer said, I got this. No problem at all. No bad data is ever going to enter our system. Somehow data got in. I don't know how. The bad data fairy just happened to arrive because we didn't have an appropriate constraint in the database preventing this. And you could argue that this particular table design is not correctly, it's not correctly designed. That's an argument for another day. We're going to deal with what we've got here. Let me show you an example, another example numerically of this particular problem. So we have Bob, and Bob has values 1 to 8, 10 to 15, 13 to 17. Well, the numbers 13, 14, and 15 overlap. That's an issue. So we go back to the business and say, hey, that thing that could never possibly happen, the developer promised us would never possibly happen, happened. How are we going to fix this? Business person says, all right, we're going to assume that the older value is correct, and then we're going to adjust the newer value so that there's no overlap. So 13 through 17 becomes 16 through 17. 13, 14, and 15 are reallocated to the older value. We may have another case like Jane down here where she has 2 through 9. She also has 3 through 6. 3 through 6 is completely subsumed by 2 through 9. So we're just going to drop 3 through 6. So this is our corrected data set. We have to figure out how we're going to do this. The way that I'm going to create this, oddly enough, is with a tally table. I start with the data table, and I'm going to inner join our tally table. Why not cross join? I just wanted to throw it up a little bit. So if we wanted to do a cross join, this would be our where clause, but it's an inner join, so it's in our join clause. I want to select the value for n, so every single number, 1, 2, 3, 4, and so on, the person, Bob, and then the earliest ID that matches that number as first ID. I have an aggregation function, and I have non-aggregated columns, so I need a group by. Group by contains the non-aggregated columns. This I'm putting into a correlated subquery. So we have that called arrangements. And from there, you can think of it, we've got this unpivoted set. Once again, we want to repivot. And now, instead of having all of the value, we just want the beginning value and the end value. So we want the minimum value and the maximum value for each first ID. And we're going to call that ID. Why didn't I just keep it consistently named ID the whole time? I think it's better for pedagogical purposes to actually have separate names so you can see what's going on. So we have the person, we've got their ID, and the new beginning values. 2 aggregation functions, 2 non-aggregated columns. I need a group by with person and first ID. So that's what I have down here. Once we take care of that, we are going to go to the demo and see what actually happens. So this is our new data table. Totally different from all the other data tables. We have some sample values that I'm going to insert. And ready, just by looking at this data, person 1 has 1 through 5 and then 2 through 7. So there's some overlap here. They'll have 2 through 2. Well, that is completely subsumed by actually both of these. So I would expect this to drop. And then I would expect this to be adjusted to 6 and 7. Those are my expectations, but see what actually happens. Inside this records comma table expression is the code that we looked at on the slide. That shows us the person, the ID, the new value for beginning, new value for ending. I am going to join that back to my data table so that we can see the old values as well. That way we can get, we can make sure that it's actually working. So for person 1, we went from 1 to 5 to 1 to 5. There was nothing earlier for person 1, so life is good. 2 through 7, however, became 6 through 7 because 2, 3, 4, and 5 had overlap. And then you'll see ID number 3 dropped completely because 2 through 2 was completely subsumed. So this process is throughout the rest of the data set, and now we have a truly unique data set. We don't have any more overlap, so we've fully assigned appropriately. And then we go talk to the developer and we make sure that the developer's constraint is actually working, and maybe we even put, heaven help us, a database trigger in to actually make sure that this will work correctly. But at least in the meantime, we now have data. So here's another case in which we have a tally table fixing what you could argue is a denormalization problem, or a not in appropriate normal form problem. And in my scenario, it was actually dates instead of numbers, but we can use both. The one thing that I'm going to throw out, though, is that in my horribly underpowered server when I had to do this, the code blew up after about 1 million rows. Granted, this was a horribly underpowered server, but still, there is an upper limit to what this is going to do. What I ended up having to do was take all of the rows that I knew were good and feed them into my reporting table first, and then take all the rows that I knew had overlap and perform this operation on those rows so that I stayed under my 1 million row kill limit. So you may have to finagle a solution, but I'd argue this is still way better than a rebar solution. Next up, let's talk about checking and filtering on dates. So what I'm talking about here is, again, with the flat files coming in. We get a flat file. It has a date column. This date column should be 4-digit year, 2-digit month, 2-digit day. However, they're sending it into us as a string. And obviously, they have some data validation questions over on their end. So looking at these particular dates, we have 1999-05-01, May 1, 1999. That's a good date. 2011, 1499. There is no month 14, so that's a bad date. This is a good date. 2011, 1305. There is no 13th month of the year. Lousy March weather. This is just text. That's not even close to a date. 9901. That's a year. It's a year way out into the future. It's not a date. June 109. This came from Excel, didn't it? And finally, here's another good date. I'm going to check and pull out all of those bad dates. Now, they could be legitimate dates, like June 109. It is a legitimate date, but it's not in the format that I need it to be in. So I'm going to take that out so that either I can report it back to the source, or I could say any of these are still actually dates and then do the conversion myself, but I want to do that in a subchannel. I'm going to use a tally table to give us the set of valid dates. So from tally, I'm going to have a start date and an end date. My start date is January 1 of 1991. It goes through January 1 of 2015. This is under 10,000 rows. This is somewhere like between 9 and 10,000. So even in this case, in this scenario where we're talking about almost 25 years, we have fewer than 10,000 rows. If you have a 100-year data set, you have to be concerned with data for 100 years, that's a 40,000 row tally table. You're not even coming close to, oh, I need 1 million rows in that tally table. 40,000, 20 pages, not that bad. The way that I'll get the date is just take date add, so the number in, how many days from start date, convert that using 1 to 2, which is the well thought out format, the convert method's well thought out formatting. That gives me YYYYMDD. I mean, it's pretty obvious from convert, obviously, that this is going to come out as YYYYMMDD, and they don't need any type of appropriate string formatting methods like in SQL Server 2012. But that's a rant for another day. Fortunately, they actually have appropriate formats nowadays, at least if you have 2012. Anyhow, here's our dates, all of our dates, 91 through 2015. What I'll do from there is join our input data table to that tally date table and see what falls out, which rows don't exist in our tally date table. That's going to tell me where my problems are. At this point, you might be asking, hey, why not use the isDate function? It's in SQL Server, and you know what? It's going to be faster than a tally table. The answer is absolutely, yeah, it will be faster than a tally table, but I have a handy chart that shows what happens. Our first result, 1999-05-01, isDate says that is a date. I agree. 2011-1499, I say no date. isDate agrees. 2009-01-01, is a date? Yes. 2011-13-05, is this a date? The answer is, in our North American data center, yes it is. Over in our Paris data center, where they have a database in French collation, it is a date. Because in the French collation, YYYY, MM, DD is not a standard. Their standard is YYYY, DD, MM. This is May 13, 2011 on a French collation. So if our validation is happening in France and inserting data into a US system, and we're assuming that these 8 digits are US style date codes, then we have a problem. For the rest of these, gibberish is not a date. Good. 901 is a date. I believe it is January 1 of 1999. June 1 of 09 is a date. Because, yeah, I mean, it's a date, but, you know, it's not in the format that we want. And finally, this is a date. So the isDate function will be faster, but it won't pick up some of these scenarios that I actually want to catch. Some of these scenarios where they're sending in data in a format other than 4-digit year, 2-digit month, 2-digit day. All right. So here is the actual code. This is what we saw, the physical tally table version. Now, I want to go back to what I was talking about earlier with the common table expression version. Here is our common table expression version of the tally table function. It's a bit more complex because, you know, we're spending all of this time building up our tally table. And our tally date function is a little bit different. I forget exactly why I did it this way, but no big deal, no big difference. The final select statement, however, is still the same. So we are going to set statistics IO time on, compare the two solutions. All right. Both of them are set of bad dates, same set of bad dates, including 2011-13-05. And if we ran this in our Paris data center on a database with French collation, we would still get that row back because we're not relying upon built-in date context that isDate provides. Looking at how these two performed relative to one another. The first solution here used the physical tally table. We had 280 reads of our tally table and one scan, one read of our built-up data table. This took us a little bit over 2 seconds, but only 94 seconds of CPU time, milliseconds of CPU time. So our CTE version did not have a scan of the tally table. We just have a single scan of our data table. Our tally table was put together in memory. CPU usage is higher, but elapsed time is lower. Part of this is because, once again, laptop overloaded. Actually, at home, these numbers were very close, but the physical version was a little bit better, with 20,000 rows. With 200,000 rows, the CTE version of the tally table was better. So performance-wise, there's not a huge between the two, especially if you're starting from a RBAR solution. You know, if you're starting from something that's low. But in certain scenarios, you may see the common table expression version be faster. So the lessons here, what I want to point out is, if you're doing things like this fairly often, I'd highly recommend, in addition to creating a tally table, create a date table. If you have a data warehouse or other decision support system, you probably have a date dimension sitting around somewhere. Take that, put it in your transactional systems. I've ended up using this quite a few times because, you know, you may think I don't need to worry about, I'll just calculate the dates on the fly. But it comes and says, I do a report by fiscal week of the year for fiscal year 2006. Yes, you can perform that calculation. If your fiscal year starts, I don't know, July 1st, then now you're performing calculations saying, oh, now I have to add 6 months, or do I subtract 6 months? I forget now. Instead of doing that, you have a date dimension that says fiscal year, fiscal week. And now you join, you say where? Fiscal year 2006. Give me the fiscal week. Group by that. Date tables are awesome. I love them as much as I love tally tables. Our final example, I'm going to skip. It's a complex example. I recommend if you go over the slides, go through it. It's kind of cool. You split out a two-dimensional array. And this actually has two separate delimiters. I think it was like commas and pipes or something along those lines. But at the same time, after that, people who went to when I talk on the cross-apply operator will probably look at this and say, hey, wait, this looks kind of similar to a cross-apply solution. And the cross-apply solution is actually better. So I'll just say, if you're interested, go through example 7. But it's kind of more advanced. I will wrap up. Tally tables are awesome. They do great things when it comes to normalizing, when you have to normalize data, when you have to deal with denormalized data. For example, you have to split out strings. You have to get multiple sets results. You have to perform error checking or generate data. We can do pattern search like filtering or finding maximal chains. And although they're really awesome, I want to say these are not a replacement for good database design. They are tools that will get you out of a hole, but they are not a reason to dig a hole. Finally, a couple resources. First 3 links all from Jeff Moden. Jeff Moden to me is the man when it comes to tally tables. I learned pretty much everything about tally tables that I know from him. He refuses to accept nearly as much credit as I want to give him. He says, hey, I learned this from guys like Van Gunn. I didn't come up with these ideas, I just learned it from them. I'm standing on the shoulders of giants. But from my perspective, Jeff is one of the giants, especially on this issue. So read those articles. They're very helpful, very informative, and very well written. The slides are available on my website. Also have demo code. Everything's up currently, so you should be able to get it now. So at this point, to ask, are there any questions? These slides are at this URL, catalexyservices.com, presentation. And I'll also post a link on the Meetup site in the comments with the slide location.
And the tonight's session will be up on YouTube on our channel. So if you want to watch it again, it'll be available there. I'll have it up there tomorrow. I'll put a link in the comment section as well.
When you said you're running things at home and you're faster, is that because you have a server at home or just faster network connection?
Okay, so the question was, I mentioned a few times that when I ran these at home, things were a bit faster. And do I run this from a server at home or what? So at home, I got a beefier desktop, but also this laptop is just because I'm running the GoToMeeting software and I'm writing out to disk, it's slowed things down quite a bit. So even if I just stopped this sharing the session and stopped writing the session out to disk, performance would change. You'd see the performance profile change a bit. All right.
Are there any questions online?
Let's find out if there are any questions online. Looks like we have scared everybody and prevented them from asking questions. So awesome. That I would consider to be a positive development.
You hear any snoring?
Well, no, I've muted everybody, so I can't hear any snoring. So anybody who's snoring, don't worry, they could hear you. So hey, thanks a lot, everybody, for coming by, listening to me talk about this for a while. I love chatting about tally tables, and have a great evening.